Data. And that's the most important thing, because I love data. Data is all my life, because I am the CIO of the ZMG. ZMG is the Austrian Meteorological Service. It's the oldest meteorological service in the world. So that means we do data analytics and data science till 8051. To be honest, not with the computers, but it's still data science or data analytics. We host a lot of data. So our business is almost 100% data driven. What does that mean? On-prem, we host about 28 petabytes of data. In our European data center, we host about 220 petabytes of data. We get 15 terabytes of data every day just from satellite data, and 100,000 data sets per minute. So to manage all this data, we need a lot of overhead, because data is nothing without information, and information is nothing without knowledge. I'm also the president of the DIO, the Data Intelligence Offensive. It's a very, very extensive network in Austria and also in Europe. We are one of the semi-founders of GAIAX, if you heard about that, IDSA and BDVA. That's the three big associations dealing with data in Europe. But let's talk about some basic things, because I'm not sure if everyone is aware of data, information, knowledge, and other things. And maybe you often heard about the term data is the new gold, data is the new oil. But are you sure about that? It was 1895, I think, where the first patents were invented on oil drilling. And the thing was, when the guys then had oil in their backyard, do you think they thought, oh, there's oil on my ground, I'll keep it there because it's worth money, and I just keep it in the backyard and don't drill for the oil and don't mine the oil. That's the thing we do with data at the moment. We keep it in our cellar, we keep it closed in our boxes. Nobody is able to access the data. You don't share the data because it's something like gold or oil. To be honest, data is just 0 and 1s. It's just power or no power. You need knowledge, experts to give this data information. And afterwards, you combine this information to new knowledge. And that's the idea of data-driven ecosystems and data-driven business development. So a lot of companies ask me, where is this data value? Where is this data treasure? Do we have data treasure? For sure, everyone has. Not only companies, you as a person, as a private person, also have a very, very big data treasure. And you pay with this data almost every day. When you use Facebook, when you use Google, when you use Amazon or some other companies who are very, very soon in this data-driven ecosystem. Google, for example, with Android operating system on the Android mobile phones, you pay with your data. The operating system is not free. On iOS devices, you also pay with data, but we also pay with your money. That's why these operating systems are much more expensive. But it's not only this treasure, so a lot of worth. A lot of companies have really, really, really good ideas on data-driven business development. Let me give you some examples. A very, very big retailer is doing predictive analytics on sales. They do it with the ZMG, with my company, and they ask how much is the impact of weather or, for example, other social data on my retail sales. Think about this situation or this case. When it's hot, it's a hot weekend, you do barbecue, you drink a lot of more water, you drink beer. So that's the easiest way to have a look that weather has an impact on my sales. But there is a lot of more impact, and 13% of impact on weather is a lot. We don't do it still with retailers. We do also do it with mobile phone companies, so telcos, who are thinking about doing some forecast on their stores, not of selling contracts or mobile phones, but also of having employees and personnel in their stores, if there are a lot of people are coming or if there are less people coming. So that means you can do a lot of optimization, for example, on data when you combine the data. So the retailer has nothing from his data and the ZMG has nothing from his data. Just the combination of the data is the key to have a new product, for example. The second example is one company, one big brick manufacturer for this big ovens, for the big industry ovens. They stopped or decreased the production of their bricks during COVID. With data science, they started to have a second level product. So the idea was to have the maintenance time of the big ovens as small as possible. And so they started to sell this maintenance data to the big company. In Austria, it's the First Alpine, it's a steel producing company. And nowadays, these second level products make almost 25% of their revenue of this brick manufacturer. So that means all over, it's also in very traditional companies where you stop having the first level products, you also have the second level products based on data science, or based on data-driven business development. A third example was one we are just inventing at the moment. There's a big key manufacturer in Austria, I think it's also in Europe, and they wanted to know when they should make a replica of a key for a person. And with data science, it's not that bad. It's not that easy, but it's also not that bad to know 1 day, 2 days, or 3 days in advance when they should produce the replica. Think about that. Me as a semi-young guy, maybe have a new girlfriend. As soon as the key company knows that I have a new girlfriend, they can do a predictive analytics when this new girlfriend will start to live in my flat, in my apartment, and the days before I give her the key, a replica is still in my post, in my mailbox, and it's a second level product as well. So you see, with data, we can do a lot of things. We can really do this data-driven business development. We can do a lot of new innovations. But what can't we do, and what do we need when we want to have some data ecosystems? In Austria, we tried to do data ecosystems, so-called data markets, about 8 years ago. And we thought it's a good idea to copy concepts like Amazon. We have a marketplace, you can put all your data inside and someone is taking the data or buying the data, and we broke the data and all the things. And it was a horrible fail. It was an absolutely fail because dealing with data is something extremely different than dealing with products. Data is very, very easy to copy. Data, in a lot of mindsets, data has no worth because it's just digital. So we started to rethink all this kind of data industry, this data ecosystem. And we had some kind of roles, what we need and how we deal with data. On the one side, you have the service providers, the infrastructure providers, the data providers. This was the first problem in Europe because we don't have hyperscalers. So it's quite easy to use Amazon, to use Google, to use Azure or Microsoft to host all this data markets, data ecosystem. But it's not so easy when you want to be sovereign. The sovereignty is a very, very big thing. And in Europe, we started then a project called Federated Infrastructure. So we were not able to copy the hyperscalers, but we were able to work together. And that's very, very important to combine the different platforms, make standards, and have a federated infrastructure. Then for sure, I have the data providers, I have the customers, and for sure the end users, because I need use cases as well to have new products. And one very, very important role, the broker. So the broker, we learned a lot of this centralized data market, and we know that centralization, it's a horrible thing for data. So the broker got a new rule. He got the rule that he's just allowed to deal with data in one domain. One domain means actually one topic. For example, mobility, for example, energy, for example, health, and so on. And then there is another second level broker who is combining these domains. What does that mean? I told you data is just 0 and 1s. It's almost nothing. You need the information, and for the information, you need the experts. And the idea is when you have this so-called data spaces, the domains, you have the experts and the raw data inside. And managing these data spaces, you can, on the one hand, have very, very easy use cases, so-called data circles, on the one hand, or combine it with other data domains and other data spaces. And to be honest, it's working. So the idea was taking this centralized ecosystem and make it decentralized. So you have this data market, not in one place, but in 1,000 places and in 1,000 domains. So the most important things are decentralization. So it's not necessary that everyone is putting his data in one place. And the second most important thing is data sovereignty. Data sovereignty means that everyone who is the data owner is losing my vocabulary. The data owner is in charge of the data. So nobody is able to change the data or use the data if the data owner doesn't allow it. Interoperability. That's one thing why data science projects often fail. 60 to 80% of the resources of a data science project are used to make data interoperable. So when you start to have interoperability as one of the key functions of data ecosystems, you save a lot of money, you save a lot of resources, and you can put all these resources in innovation, in product development, and so on. When we share data, me and you, for example, there is one very important thing: trust. Trust means, how do you use my data? Get into trust on two ways. One is the technical way. Think about blockchain, smart contracting, or digital watermarking. And the second thing is an organizational way, when you build trust networks, and there also the data spaces and data circles came in charge. I already mentioned domains and also sustainability. I will talk about sustainable data in a few minutes, but it's also a very, very important factor and has a lot of impact at the moment. So, how to use all this factor in one process? We call it GAIAX. GAIAX is an European funded project, funded with I think 32 billion euro at the moment. And this project is a framework with a lot of domains. You see it on the data ecosystem path. We have the industrial, smart living, energy, health, mobility, financial, and so on domains, which can work interoperable with identity and trust, sovereignty, federation, the infrastructure, and compliance. Beyond that, we have a lot of infrastructure there. We have high performance computing, we have edge computing, we have platforms, also the hyperscaler are involved. And what is the most important thing? How to use it, the governance, how to use the data, how to use the infrastructure, and how to implement trust, sovereignty, compliance, and decentralization. So, but let's jump a little bit to sustainable data. It's a very important thing on the ZAMG, because actually we calculate all this climate change, we calculate all this glacier science, and we use a lot of data on that. So we should think about, is our data sustainable? Actually, yes, because at ZAMG, we implemented a big process where we got some certificate on our data. If our data is green, for example, which sensors are this data made of? Are these sensors sustainable? Are they made of some special materials, or are they made of materials where there's less carbon dioxide footprint? Where is the data stored? When you think about storing in the cloud, you need a lot of energy, you need a lot of resources, you need a lot of cooling when you calculate or also store the data. So in this whole process, we developed a certificate, a green data certificate, and we only use this data for our analysis, for our science work. That's something very, very important. To be honest, also in our data centers, we cannot use just solar energy or wind energy, but we try to have a lot of them. And with the other part of the energy we need, we try to use green energy to make our data sustainable. That's very, very important and has very, very high impact for the future, for example. I can talk about that the next 2 hours, but I won't. Let's talk about data governance. Data governance has a lot of questions because everyone wants to do data science and data analytics, but what we need are the basic questions. Which data do I have? And how can I use the data? Can I use the data? Can I connect the data? To be honest, a lot of very, very big companies cannot answer these questions because they have no data governance. So at the moment, I get a call every 2 or 3 days from very, very big companies who ask me, how can I start to make data science, to make data analytics? And I tell them always the same thing. Do you know which data do you have? Do you know how to use your data? Do you know your license? There are very big companies, I'm not allowed to tell the name, but there are railway companies, for example, who don't know which license they have on their data, for example. That's quite a big problem. And when you don't have this data governance process, you cannot do business analytics and you cannot do data science and later on also business development out of data. So data governance, also like data itself, has the key is knowledge, the key is information. So when you think about how you deal with data, it's a three-pointer. Actually, the key information is it's not a software you buy. You have to buy knowledge about your organization. That's the most important thing, because a lot of companies think when they buy Colibra, Informatica, Click, and you name it, all these software products, they can do the governance process. Actually, they can't. They need stewardship. They need data governance stewardship. They need an organizational knowledge to deal with the data. And the main problem, of big companies is that this data governance process costs a lot of resources, absolutely a lot of resources. I had one company, they tried to do data governance. It's a company with 15,000 people, headcounts, and they tried to do data governance. They have about 16 departments, and they tried for 5 years because it's almost impossible to do data governance when you do a centralized data governance. You remember I told you, stop doing it centralized, do it decentralized when you go into data ecosystems, and also with data governance. Don't do centralized data governance, do it decentralized. When you do decentralized governance, you can do it in the departments, you can do it in the teams, and what's the big benefit? You have the knowledge in the departments and in the teams. So when you do decentralized and have a very good method governance about it, that's the key, and that's the new big thing in data science and in data ecosystems, and that's called Agile data governance. So what do we need when we want to do data science and data analytics? For sure, we need some kind of data hub. That could be a single point of database, that could be a data lake or a data sea. The most important thing, it's no centralized infrastructure, it's a decentralized infrastructure connected with other infrastructures. So one data hub could be mobility, for example. One data hub could be climate change, meteorology, or something like geophysics in my case. And all of these data hubs have a lot of some divisions, some layers needed to work with data. And when this is my homework, actually, this 7 points are my homework. I have to do my governance, my decentralized governance. I have to do metadata. Metadata is just data who describes my data, because when I have a lot of zeros and ones and some numbers and whatever, I don't know what to do with my data. So it's a good idea that someone is explaining me what my data means. That's metadata. There's also the license is one metadata. The title is one metadata. The timestamp is a metadata, and so on. So be sure to have a good metadata layer to use it, and then after that you can combine the data much easier. Then for sure, I have a connecting layer. How can I connect the layer, the data with other data to generate new knowledge? That's very, very important. And what's the most important key in the connecting layer? It's the standardization. Actually, there's no standard, or it's de facto standard or industrial standard, but there's no defined standard in the connecting layer. So you have to do some or use smart interfaces, machine learning interfaces, artificial intelligence interfaces to connect the layers and connect the data in an easy way to save resources. For sure, then we have identification and trust. So I told you before, the trust thing is very, very important, and it comes with the next layer. Contracting rights, service level agreements. When we want to do a data ecosystem and want to do products out of these ecosystems and new ideas and innovations, it's too less to have just data there. And sometimes it's working and sometimes it's not working, like in Zoom, for example. You need service level agreements because I want to sell my product to another guy, and I want to prove that this product is working 24/7, for example. With the connecting layer, it also comes an API management. API stands for application interface, to get all the data out of applications and to get data into applications. For example, to combine it, to share it, to connect it, whatever. I need a smart application interface management to work with the data. And last but not least, I have my storage tiering. That means where should I store my data? Should I store my data on-prem? Should I store my data in the cloud, for example? Should I store it decentralized at my customer, for example? That's all I have to think about when I work with data, and when I do my housework, my homework, then I have a very, very good data ecosystem in my company and the other company as well, and I can combine data, and I am the data front runner. So this is an example, for example, with a data space called mobility. We have on my cubes, I have other data hubs who work together, who connect to the data space mobility, for example, logistics, production, or forecasts. And my circles, on my circles, I have some use cases, so-called data circles, where the trust and the IPR is inside, with several stakeholders. The red ones are from the ZMG, from the Austrian Med Service. The green ones are external ones. We can do new ideas, new innovations, or just optimizations in the supply chain management, or in the traffic control together with cities, with companies, with the Austrian Railway, and so on. And when I start on that, I become a really small data ecosystem, and then I combine more and more companies, this ecosystem is growing. And that's the actual state of the art, to be honest, because this data ecosystem is growing. And only the ones who are participating in such data ecosystems will be the winners. Yeah, this is some data spaces actually in Austria. We have new ideas for mobility for handicapped people, supply chain management, to optimize logistics supply chain, for example. When you think about Vienna, the weather impact on logistics is 100,000 euro per day in Vienna. So to optimize it, there's a lot of business cases inside. Customer service forecast, we already had today, or predictive maintenance, which is a nice business case, but could also save lives. Think about bridges or tunnels or something like that. So, and when you have the whole big picture about mobility, you have this mobility ecosystem. You can do a lot of services. You have a lot of stakeholders, and everything of that is just data-driven. So we call it a Cambrian data explosion. The Cambrian was the time where the fishes went to the land, from the sea to the land, and it was a really explosion of a new bio ecosystem. And starting before Corona, but got a really power up during Corona, we have this new Cambrian explosion. And I really have to tell you, be part of it. That's very important.